Okay, so the instructions for numbers 1, 2, and 3 say determine whether the set of data shown below displays exponential behavior. And then we need to explain our answer in words. So first we're going to look at our x's. For exponential behavior, our x's count up by an additive pattern. So notice as we go from 0 to 1, from 1 to 2, and from 2 to 3, we're just adding 1 each time. So our x pattern is plus 1, plus 1, plus 1. That's additive. Now we're going to look at our y pattern. As we go from 5 to 10, from 10 to 15, and from 15 to 20, what are we doing? Are we adding or are we multiplying? Well, to get from 5 to 10, you could think of that as, well, maybe we're multiplying by 2. But then look at from 10 to 15. We're not multiplying by 2 to go from 10 to 15. So this is not multiply by 2, multiply by 2, multiply by 2. This is adding. This is adding 5, adding 5, adding 5. So you might have to look at a few steps down the line to really see the pattern. So remember that exponential behavior requires y to increase by a multiplicative factor. So this is not exponential. So our answer is no. And now we need to explain why. No, because y does not change multiplicatively. There are so many ways we could describe this. You don't have to use the word multiplicatively. You could say something like, no, because y doesn't change using multiplication, or the pattern isn't using multiplication, something like that. So, but you need that word multiplication in there because that is exactly the pattern we're looking for, and we don't have that pattern. So it's as simple as that. Why don't you take a look at numbers 2 and 3 and see if you can answer them on your own. Now, I will say that both of these problems have a little bit of a trick to them, so you might have to pay close attention to what's happening in your pattern. But now we're going to move on to a few problems that are quite different. In 4, 5, and 6, you can tell just by looking at them, our instructions are very different from the last 3 problems. For these, we want to graph each function, and then we're going to answer some questions about the graph. So I'm going to do number 5 with you. Be careful. Make sure you write your answer on the correct number. I had students earlier who accidentally wrote their answer in for the number 4 space. So we're on the right side of the page. We're doing number 5. We're going to start just by drawing a graph. In order to do that, we need to pick some random x values. So I'm going to make a note here. We pick these. And we can pick anything we want, but let's be smart. So our x-axis is here, and our y-axis is here. So let's make sure we actually pick values that will fit on our chart. Our x's count up by 1s, so maybe we can do... So our y values count up by 2s. That's something to note. So our y values are actually like that. Okay, so I'm going to pick, how about -1, -2, -3, -4. My graph goes all the way down to -4 and all the way up to +4, so that's about as far as I can go to the left and the right. And then we want to make sure our x values are evenly spaced, so let's count up by 2s. So we'll do -4, -2, 0, 2, and 4. These just so happen to be the same values we were using yesterday when we were doing problems like these. We're just going to try to pick values that kind of fit on our graph, and these tend to work quite often, so you might end up using values like this pretty frequently. Okay, so once you've picked your x values, we didn't have to pick these, by the way. We could have gone with like -2, -1, 0, 1, and 2. So I just chose these. Now let's find our y values. So this is going to require us to plug in. So for our first y value, we're plugging in x is -4. Well, guys, This exponent stuff gets a little challenging, right? We've got negative exponents. That's going to create fractions. We got all kinds of weird stuff going on. So here's what I want you to do. I want you to pull out your calculator. So type in to your calculator 2, and then the power button, which looks like a little carrot facing up. And then inside your exponent, we have -4. So we're typing in 2 to the -4. Enter. That should give you a decimal number, right? Like 0.0625. Well, we also have -1 at the end of this problem. So now type in -1, and you should get -0.9375. Woo! Is anybody having an issue when they punch this into a calculator? Syntax error? Okay, what are you trying to type in?
2 to the power -4.
You're using the minus sign instead of the negative sign. So the minus sign is kind of a gray button on the right. The negative sign is at the bottom in parentheses. So make sure you're using the negative when you type in -4. Is anybody else having a syntax issue or a problem getting this to work? All right. So that's our y value for this box here, -0. I'm going to just type in 0.94 or write in 0.94. We'll round it a little bit. And so now we need to draw that point on our graph. So -4 comma -0.9 is really close to -4, -1. So we're going almost all the way down to -1. Not quite there, but really close to -1. Now let's figure out what our next point is. So this time we're plugging in -2. So we'll take 2 to the -2 minus 1. So use your calculator, punch in 2, power button, -2, and then you have to subtract 1 from that. Did everybody get -0.75? All right, let's draw this point on our graph. -2, comma, -0.75 will be about here. It's a little bit higher up than the one we just put on our graph. And now it's time to put 0 in. So y equals 2 to the 0 minus 1. We probably don't even need a calculator for this one. Anything to the 0 power, well, that's always just 1. Anything to the 0 power is 1. But then we're subtracting 1 from it, right? So we get 1 minus 1, which is 0. I just decided I'm going to do these in red. So our next point is 0, 0. Now let's plug in 2. So we'll get y equals 2 to the 2nd minus 1, which is 4 minus 1, which is 3. That'll give us the point 2 comma 3, which is about there, I think. Halfway between 2 and 4. And our final point is going to be y equals 2 to the 4th power minus 1, which is 16 minus 1. Okay. This is going to be way up there off the graph. No, never mind. Our graph counts by 2's. So this goes 2, 4, 6, 8, 10, 12, 14, 16. 16 should be right here. And now we're going to connect all of our points with a curved line. Try to get this as accurate as you can through your points. I know it's tough. And then remember, on the left side of your graph, this line is going to kind of level out. And it's sort of just going to shoot off to the straight left. Okay, so that's how you draw your graph. Now that we have this drawn, we can answer questions about it. So the first question is this graph a growth or a decay? Does it increase as we read from left to right, or does it decrease? Is it going up or down? And this one's going up as we go from left to right. So it's a growth. We can also tell by looking at our base. The base of this exponential function is 2, which is bigger than 1. So if your base is bigger than 1, it's going to be a growth. Next, let's look at our y-intercept. Our y-intercept is the point where our graph crosses the y-axis. It's the point where our x value is 0. That would be this point or this point. A couple different ways we could think about this. So when our x value is 0, our y value in this example is also 0. So our y-intercept is 0. The asymptote is the line that our graph is getting closer and closer and closer to, but it's never actually going to cross it. So that would be y equals -1. And your asymptote and your range go hand in hand. If your asymptote is y equals -1, your range is y is greater than -1, right? Because our function is above the asymptote, greater than. I skipped over domain, but domain's the easy one. The answer for domain is always all real numbers. And finally, they ask us one more question. What is y when x is -4? Well, that's on our chart. That's on our table. So we can use our table to just fill that in. -0.94. We can kind of round it a little bit. So this is just an exercise in kind of reading your table, reading your graph, and finding some information about these things. I would like you to spend the rest of the class period working on 4 and 6. This is for credit. So here's the deal. I'm not going to have time to check your work. I don't think most students got finished. So you have two choices. You can snap a picture of it tonight and submit it that way, or you can just turn everything in at the end of the week. You can just hand me your entire packet on Thursday, and I'll grade it all over the weekend. So that gives you a couple extra days to get these problems finished and ask some questions about it if you need some help. Does that sound good? All right.